Hello all, welcome to this NIA SDC Storage Conference. I am Kanna from MSys Technologies, and today I am going to present paper about future of long-term archival data storage, DAM. Before going to see in detail about the session, I like to say a few words about MSys Technologies. Okay, MSys Technologies is one of the top storage companies in the recent years, and we mainly focusing on storage, virtualization, networking, cloud, and we have the offices at different locations across the world. And our outsourcing partners are HP, Chef, Rubrik, Google, IBM, and these are the key alliances. Let's go and see about the agenda of our today's session. First, we are going to see about the data storage devices. In this, we are going to see about what are the various devices we are using to store the data. Then we are going to see about problems with the current storage technology. Then we are going to see about data storage in DNA. In this, we are going to see how we are storing the data and what are the process we are using. Then we are going to see about advantages and disadvantages of DNA. And finally, we are going to see about why DNA is the future of organic storage. And we all know, right, in this digital world, the data plays a crucial role in everyday's life. And with all this latest technologies and devices, we are generating more data and storing more data in the recent years when compared to all these years. As we are generating more and more data and storing more, do we have option to store all the data? And even though if we store the data, are we able to retrieve the data in the long term? So to find the solution for this, we need to understand about how the data getting stored and what are the various technologies we are using to storing the data. Currently, all our data stored in hard drives, it may be either HDD or SSD and tape drives. And in the past, right, we also stored the data in the optical videos like the CD and DVD. But none of this device stand with the test of time. So basically, we can able to retrieve the data in certain amount of time, but in the long term, we can't able to retrieve the data. Either we should copy the data to the another device to keep the data safely in the long term. This picture represents the evolution of storage from the past history to the current data storage devices. And our modern data storage techniques have few problems. This is not robust and low information density, and each media requires special device to read and write the data. Let's see each problems in detail and how DNA helps to overcome these problems. First, we are going to see about the robustness. We all know hard drive is unreliable with 1 to 3% of drives drying within the first year, and it goes up to 10% within the subsequent Yes. So with this, it's really very difficult to store the data in the hard drives. In the case of tape drive, it is comparatively better than hard drives, and we can store the data up to 30 years. But the way we generating the data, we need to store enormous amount of data, and to keep the data safely and retain the data in the future, we need to keep copying it into the newer drives. That's really a big problem for historical data, which could be invaluable in future. DNA, on the other hand, is very robust. Here, right, we can able to retain the data, even the past history data, even it's stored long time back also, because a DNA is the nature storage medium. So we don't need any special device to read the data. Whatever the reader right now we are using to read the data, right? We can use the data even though if the data stored very long time back. For example, in 1991, the mummy of Otzi, the Iceman, was found in the Alps. He died over 5,000 years ago, but still we are able to extract his DNA, read it, and find out that he was lactose intolerant and that he has living relatives in Austria today. If OC had been carrying a hard drive or any other device with him, it's really very difficult to read it 30 years after his death. So because of this robustness, DNA is very useful storage media. So this picture represents what we discussed right now, right? Density. The second problem that we currently face is information density. Okay, for example, right, the Facebook cold storage data center in Oregon is over 5,000 square meter in size and can store approximately 1 exabyte of data, that is 1,000 petabytes or 1 million gigabytes. To store all of the data that was generated in the last year, we need 33,000 of these kind of massive data centers. In DNA, theoretically, we can store 1 zettabyte of data in the single gram of DNA. Currently, we can only store 250 petabytes per gram of DNA, which means we can replace Facebook's entire data center with just 5 grams of DNA. So because of this, by using DNA, we can store all of the world's data in a very small footprint. It means that we don't have to choose what data we want to preserve for future generation. We can just store everything in the DNA. So this pictorial representation of the DNA, how we can store the DNA in the tube. And the third problem is specialized readers. What is specialized readers? For every advancement in storing data has required a new way to read. For example, we all know, right? The floppy disks are very popular in the 80s and 90s, but now we can't use them. In whatever the latest device, laptop or whatever the device, right? We don't have options to read those. And the same applicable for optical media such as CDs and DVDs. By contrast, DNA was not a human invention. It's been around since the beginning of life and always had the same properties. DNA readers or sequences built today can read all DNA, even old DNA, like the one from Iceman OC that we saw in the previous slides. So just to summarize what we seen so far, right? So over the decades, storage technologies has evolved and gotten better, and the data stored from the CDs and floppy disks moved to hard and solid state drives. But still, we have a problem. What is the problem? The amount of storage available and being produced can't cope up with the data that we keep producing. And DNA data storage is the only solution to this problem. Now we see how the data gets stored in the DNA and what are the process we are going to use to store the data in DNA. What is DNA? DNA stands for deoxyribonucleic acid. It is a complex organic molecule that carries the genetic information of a living thing. It is found in all humans and store information like skin color, height, and other physical and biological traits. Basically, it is the nature's oldest storage device. DNA data storage is the process of using DNA molecules as a storage medium. DNA data won't be stored in binary digits. Instead, here we store it as a DNA nucleotide bases ACGT. Basically, this is the DNA codes that we are using to store the data. Then it converted to binary digits when needed. A DNA spiral has multiple and alternating pairs of four unique bases. They are adenine, guanine, cytosine, and thymine. These bases are attached to the DNA spiral in pairs called base pairs. The two base pairs are adenine, thymine, and guanine and cytosine. The DNA data storage comprises three processes: coding the data, synthesizing and storing it, and decoding it. For encode and decode the data, we use the special software which converts binary bits into DNA codes and vice versa. This picture clearly explains about the DNA data storage process. We have the data binary digits, then by using the special software, we encoding these binary data into the DNA code. Then we are writing the data. That process is called synthesize, then storing the data. Then if you want to read the data again, you can read the data, and that process is called sequencing. Then again, by using the special software, we decode the data, which converts from DNA code to binary codes. binary codes holding information are translated into DNA codes. Then they are deposited in a container in a cooled regulated environment. The DNA carrying information can be frozen in a solution, stored as droplets, or stored on silicon chips. DNA data storage. This is the first bit of DNA. Let this take this as an example. To store something digitally like this photo, first we convert this into the binary digits like 1 and zeros. Then after this binary digits converted into the DNA codes ACGT. Then we write the data, basically the process called sequencing. Then we can store this data. And when we want to recover our data, we just read the data, sequence the data. So DNA data storage capacity. DNA data storage is the preferred solution for the storage shortage problem because it can store large amounts of data in very tiny space. 1 gram of DNA can store 215 petabytes of data. A petabyte is 1024 terabytes, so 1 gram of DNA can store approximately 2,20,160 terabytes. What are the advantages of the DNA data storage? So, DNA data storage provides high data storage capacity, longer lifespan than other forms of storage, compactness, low susceptibility to technical and electrical failures, and replicability. So, the major advantages are storage density, durability, replicability. Storage density. The main advantages of DNA storage over other storage medium is storage density. Usually we store our data remotely on the cloud or NAS, but still they are stored in the big servers and data centers. These data centers are as large as football stadiums and cost billions of dollars to build and maintain. But it's not the same with the DNA data storage, and we see that right by 1 gram of DNA, we can store enormous amount of data, so we can avoid those large space and $1 billion to build and maintain it. Durability. The digital storage equipment available today is far from durable. They are all prone to decay and degradation. Digital decay is the gradual decomposition of data stored on a computer, affecting millions of people. If DNA is stored in an optimum and regulated environment, data stored in a DNA can be available for more than 500 years. Then replicability. We all know, right, because of the data degradation, the data in the data centers have to be copied and transferred onto the other hardware in regular intervals to keep the data safe. In DNA, the data stored can easily be replicated, and we have a lot of methods to do the replication. And one method is to insert the DNA with stored information into a bacterium. This bacterium then reproduces on its own other generation of bacteria that possess the same information stored in the first DNA without any errors or loss. Now we are going to see about what are the drawbacks of DNA. The two main drawbacks are cost and speed. Creating or synthesizing DNA is a very expensive process compared to hard drive. Reading or sequencing DNA is a bit more affordable but time consuming because here the entire DNA has to be sequenced even if you want one small part of it. But to overcome this problem, Microsoft recently come up with a new technique that allows us to randomly read parts of DNA. As we see, right, the advantages and advantages of DNA data storage with the other storage medium. So DNA data storage is the future of data storage. With all these advantages, right? A DNA data storage is the future of data storage, but it will take some time before we can phase out our trusty hard drives. Cost and speed are the main factor to consider, and lot of research going on to reduce the cost and speed to store the data, and it's only matter of time to achieve it. Maybe soon or in a couple of years, we can store incredible amount of data in a very small space, and we will be able to archive the data for future generations. Thank you for attending this session. And I like to say a few words about me. I am Kanna, working as a senior test manager in MSys Technologies with 15 plus years of experience in data storage. And I have very good experience in testing various storage vendor products. And I have very good expertise in cloud storage and managing multi-cloud infrastructure by using Terraforms and expertise in good Kubernetes self-storage, Red Hat Ansible. I'm currently working on a cloud storage with the AML project and edge computing. And also, I am the Oracle Cloud Certified Practitioner and Certified Scrum Master. And these are my contacts. If you have any doubts and if you need any more information about this topic, feel free to contact me. Always your feedback is important to us. Please take a moment to rate this session. Thank you. Thank you very much.